What's happening, dogs? Mr. Allen here. We're about to do this dope application problem with the one and only Harry Styles, who is starting a new side hustle company making open top boxes. Now, the company slogan is, our boxes have so much style, get it? We couldn't put a lid on them. What is the largest volume box that can be made from a 24-inch by 40-inch piece of material? Well, here we have our 24-inch by 40-inch piece of material. And what's going to happen is we're going to cut out each one of these four corners, which allows them to fold up these sides, creating an open top box. These folds are going to occur along the dashed part, making a new base of this box here that's smaller than the original piece of material. How much smaller is it than the original piece? Well, when I fold this up here, that's going to become my height for both of these, right? Both folds, everything's going to become the height. Now I need to look at what my base dimensions are. And why am I wanting to look at all my different dimensions? Well, the volume formula, a volume is equal to the length times the width times the height. I have my height, but if I want to plug this into my handy-dandy graphing calculator, I'm going to need everything in terms of one variable. Well, why don't we just get everything in terms of the height? Okay. Well, this, let's call it the length right here, is 24 inches, but then I would be taking off that height and that height. So this new length would be 24 minus 2 times my height, right? 24 minus height, 24 minus 2h. And in the same regard, I can do that for my width, which would be my other dimension of 40 inches, but I'm taking off that height there and that height right there. So we'd have 40 minus 2h. Now I have a length, a width, and a height for my volume as a function of only my height. Let's write that up. I decided to put my original height first, just looks better that way, and then I have my length and I have my width. Doesn't matter what order these are all in, as long as all three of these individual pieces exist in my function. Now, let's bust out that bad boy, plug it into my y equals. And from here, I'm going to hit zoom 6 so that I get into the standard 10 by 10 by 10 by 10 window. We'll see what we can see. I don't know if we're going to see everything. Unfortunately, I just see one vertical blue line. So I think I need to expand some things here, right? So I'm going to go further to the right and way the heck up. So let's adjust our window to, how about for my x max? Let me look at these individual dimensions here. Here, the largest number I could plug in would be 12 before I go to 0. And here would be 20 before I go to 0. So realistically speaking, my h dimension, my height, needs to be between 0 and 12, but I'll go all the way so I can see this one too. Let's go even to, how about 25? We'll see a good amount of this cubic function. How the heck did I know it was cubic? 1, 2, 3 h's multiplied together gives me h to the third. So, not h to the Izzo. Jay-Z reference. All right, so my y max, I don't know, let's just go, I'm going to go like 10,000. I'm taking a wild guess here. Ooh. I mean, a little high, but I can see this thing, right? I can see the important stuff that's going on with this particular graph, right? I'm looking for my maximum between that 0 and 12 portion here. That's my feasible domain, right? My realistic domain for this particular problem in the context of this problem. These are all good math words, bro. All right, so now I'm going to find my max. So I'm going to hit second calc, and then I'm going to choose maximum. Then I'm going to arrow to the left of my perceived local maximum, hit enter. Then I'll arrow to the right of my perceived local maximum, hit enter. And then for guess, I'm going to hit enter one more time, and it will say maximum and gives me x equals 4.85 and change, and y equals 2,101.45 and change. So what the heck does this stuff mean? Well, let's remember that my x is my h. So that means that my height, the h, is equal to 4.85 inches. And then my y value, that's my volume. So my volume is 2,101.458, so 46 inches cubed. Now for this one, it says, what is the largest volume box that can be made from a 24 by 40 inch piece of material? It's only asking for my volume here, so this would be my final answer in this problem. Now, if I wanted my dimensions, right, if I wanted my dimensions, I could take this 4.85 and plug it in for h here, do 24 minus 2 times that. That would give me my width or my length, and then I would plug that in for the other one as well, and that would give me my other dimension. I'd have all 3 dimensions. That'd be dope, but this one just asks for the volume of the box. It's 2,101.46 inches cubed, and that's awesome.